Okay, so we're going to be working on a Pendulum Lab. I'm going to just kind of show you how you might take some data and analyze it to get started. So this is a pendulum. We have a string attached to a hanging mass that we'll call a bob. By the way, what we're using for the bob, these are made of lead, which is toxic. So if you're careful with it, you'll be fine. Really, just you don't want to put it in your mouth, which I don't think any of you will, because we're not first graders. And then when you're done, you should wash your hands, okay? And that's really all you need to do to be safe with lead. There shouldn't be much coming off on your hands anyway, but just to be safe, when you're done handling it, wash your hands. So what we'll be doing though is we'll be measuring what we call the period of the pendulum, or how quickly it oscillates, okay? So if we were to take a stopwatch, okay, and what we'll do is we'll hold it to some angle, and we're going to time it for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 complete oscillations. Okay, once we've done that, we're going to then go to our data analysis. So let's say that for those 10 oscillations, it took about, so let's say for the 10 oscillations, it took about maybe like 10.7 seconds, okay? And so the way that we would find the period, or the amount of time, so we use a capital T to represent the period of oscillation, or the time for one oscillation. The way we find this is by dividing the total amount of time something was oscillating for by the total number of cycles or oscillations. Okay, and so in this case, the period was 1.07 seconds, or this basically means that for every time the pendulum swung there and back, it took 1.07 seconds. Okay, so let's say that I had another pendulum that completed 10 oscillations in 8.3 seconds. Okay, what would be the period for this oscillating pendulum? So to find this, we would divide 8.3 seconds by 10, and we get 0.83 seconds for one oscillation. Okay, so you're going to use this to take data, and this counting of 10 oscillations allows us to eliminate some of the error that is introduced by a reaction time using a stopwatch. Okay, when we start investigating pendulums. As we do investigate pendulums, one of the things that we're going to explore several things, but pendulums are a really interesting, I guess, system, because they're very predictable, and in fact that's why we use them as metronomes when we are playing a musical instrument. We need to keep time. We use them to, they've often been used for clocks in the past, to keep time on a clock. And there's some very clear factors that affect the period, or the amount of time it takes for the pendulum to complete one oscillation. And so that's kind of what our goal is to investigate in this next lab. And the variables that I'm going to have you look at are the length of the pendulum, the amount of mass that the bob has, okay, the angle that you release the pendulum from, and then there is one factor that may play a role, but we can't really investigate here, and that's the strength of gravity. Okay, and since we can't change how strong gravity is in this classroom, for this part we're going to actually use an online simulation. Okay, because that's a place where we can simulate different strengths of gravity and see how it affects the pendulum. And so your goal is going to be to see which of these four things impact the period of the pendulum and which one causes it to have the greatest impact. Okay, right off the bat, which one do you think here, looking at these, would make the biggest effect? And do you think it would make it go faster or slower by increasing that value?